Hello students. Welcome to the YouTube channel, Physics Simplified. In this video, we will discuss one of the special cases of the oblique projectile motion from a horizontal plane. So, without any further delay, let's jump into the discussion. For the oblique projectile motion from a horizontal plane, here we will find the minimum speed with which a projectile must be projected from the origin, so that it is able to pass through a given point on its path. According to the figure, a projectile is projected from point O, with velocity u, at an angle theta with the horizontal. The coordinates of the given point P, through which the projectile passes are m and n respectively. By considering the point of projection O as the origin of the two-dimensional coordinate system, the x-axis is taken along the horizontal direction, while the y-axis is taken in the vertically upward direction. Now, to minimize the speed of projection, the angle of projection must be adjusted accordingly. Let us now write the equation of trajectory for this type of projectile motion. It is given by y is equal to x tan theta minus gx squared divided by 2u squared cos squared theta. We mark this equation as number 1. Since the projectile passes through the given point P, hence, substituting the coordinates of P in equation 1, we get n is equal to m tan theta minus gm squared divided by 2u squared cos squared theta. Since 1 by cos theta is equal to sec theta, hence, the equation modifies to n is equal to m tan theta minus gm squared divided by 2u squared times sec squared theta. We know that sec squared theta is equal to 1 plus tan squared theta. Using this formula in the previous equation, simplifying and rearranging, we obtain gm squared tan squared theta minus 2mu squared tan theta plus 2nu squared plus gm squared is equal to 0. If you follow this equation carefully, it is a quadratic equation in tan theta. Now, the projectile will pass through the given point P if this quadratic equation gives real roots. This means that the discriminant of this equation must be greater than or equal to 0. To find the discriminant of this equation, let us first write the standard form of the quadratic equation. A x squared plus bx plus c is equal to 0. Discriminant of this equation is given by b squared minus 4ac. Now, comparing our current quadratic equation with the standard form of the same, we find that gm squared is analogous to a minus 2mu squared is analogous to b and 2nu squared plus gm squared is analogous to c. So, discriminant of our quadratic equation is 4m squared u to the power 4 minus 4 gm squared times, within first bracket, 2nu squared plus gm squared, and it is greater than or equal to 0. Performing these steps and after simplification we obtain u to the power 4 minus 2 gnu squared is greater than or equal to g squared m squared. Adding g squared n squared on both sides of the equation, the left-hand side of the equation simplifies to u squared minus gn whole squared. Again simplifying the equation by performing the steps, we obtain u squared is greater than or equal to gn plus g times under square root m squared plus n squared. Therefore, u is greater than or equal to under square root gn plus g times square root of m squared plus n squared. Since we are concerned with the minimum speed of the projection, hence, the minimum value of u from this equation is given by u suffix min is equal to under square root gn plus g times square root of m squared plus n squared. So, if the projectile is projected from point O, with this minimum speed, it will definitely pass through the given point P, situated on its trajectory. Furthermore, if we substitute this minimum value of u in our quadratic equation and do some calculations, we get the angle of projection as alpha is equal to tan inverse of u squared divided by gm.